Welcome to Programming Rainbow. In this video, we will continuing on the beginner's guide to SDL2 in the Odin language. This is video number 2. So if you're just starting out with this video, you'll want to go to github.com, Programming Rainbow, and this repo will be called Beginner's Guide to SDL2 in Odin. You want to clone this repository, move inside of it, and since this is the second video, the code that you'll find at the very top will be the final video's code. So you can delete this file, this main.odin file, and you can copy the file from video 1 into the top level directory, and you will be where we are on this video. Okay, so we just finished off the last video, video 1, where we opened a window and it stayed open for 5 seconds and then it closed. Let me just show this to you real quick. So we're going to open the window and it's going to stay open and it's going to close after 5 seconds. Now we can't close it. If we try to close it, the operating system may actually say that the window is not responding, but it's going to close itself after 5 seconds. So what we're going to do in this video is we are going to start checking events and we will be able to close it 2 different ways whenever we want it to close, and we'll actually create a game loop. So it's easier for me to show this in the C SDL stuff, but just know that you can also look it up in the package golang.org vendor SDL2, and you can look at these things up. This site shows you the actual function definitions or procedure definitions, but it doesn't really give you an explanation. So the actual libsdl.org website for SDL2, it gives you an actual explanation, so that's why I'm using this one. What we want to do is we want to be able to go through all the events that happened. For one, we want a game loop. We want a game to basically check events, then to update its state, and then to draw itself. Okay, so let's just go kind of make that first. So right now, our main procedure is setting up an exit status. It's creating this game, an instance of this game structure. It's deferring an OS exit with the status. It is deferring the game cleanup, and then it initializes the game. And if it fails, it exits status to 1 and return. If it doesn't fail, it's going to then clear the screen, present the screen, and stay open for 5 seconds. So there's no actual game loop happening here. So I'm going to make a new procedure called game run. And this is again over here. If we were to look into video number 2, we will see there is a procedure right here called game run. And we're passing in a pointer to the instance of the game that we have. So I'm going to call it game_run. Proc, and we need to pass in this game, and I'm just going to pass it in and call it G, and it's going to be of type pointer to game struct. So this up here is the game struct. So I'm saying the type of this G is a pointer to a game struct. So when I do call this run down here, I'm going to get the address of the actual game instance, and that will be the pointer. I'm assuming you already kind of understand pointers and addresses and all this. So our game loop is going to stay open indefinitely until something tells it to close. So I'm just going to have a for. So this is kind of like a while true. Like if I was in another language and I just wanted a while loop to run forever, I would say, while, like in C maybe, let's say while true, which would just be an infinite loop. I don't need to actually do that here. I can just say for. And that will be an infinite loop because I didn't put any kind of expression that evaluates. So it's just always going to be true by default. And so what we can do is we can take this here. I'm going to delete this, but I'm also copying it. I'm cutting it. So I'm going to run this game. I'm going to call this game procedure right here. And we do need to pass in the address of of our game instance right here. So we're not actually copying the whole structure, and we're passing in the address of it. Okay, and I'm going to put in here now. Before we were using this to keep the window open for 5 seconds, but now this is a loop that's running continuously. So it's clearing, presenting, waiting 5 seconds, then it's going to clear again, present again, wait 5 seconds. That's a very slow game loop. You know, that's if you were playing a video game and every frame showed to you for 5 seconds before it went to the next frame, you wouldn't really like that. Most games, we want to at least see them running at 60 frames a second. So if we were to take 1 second as, say, 1,000, if we were divide it by 60, we would get 16. Or we'd get 16.666, and the sixes would go on forever. But close enough is just going to be 16. So instead of 5 seconds, I want it to delay for 1/60th of a second, thereabouts. It's not a perfect thing, but it's close to 1/60th of a second. That means this for loop is going to be running. It's going to clear, present over and over again around 60 times a second. Okay? So this is the drawing part. So we kind of want our events to be checked. We want our state to update. And then down here, we are drawing. Okay? Okay, so this should be G now, because I named it G up here. So this is G. There we go. And so it's the events is what's going to happen with it's checked whether we have asked the window to close. Like if you have the little X in if you're in Windows or Mac OS, you might have a dot on the other side. In Windows, you might have an X over here. And if you click that, that's actually telling SDL that you've requested that this application be closed. And that's an event. Or for us, we're going to set also pressing the escape key will close it. So those are events. Right now, they're not set up at all. So it would just ignore those events. That's why we had it stay open for 5 seconds and then closed it. So we want to check these events. So the way that we can get a queue of events that have happened since the last loop. So think about it this way. Imagine there is no events. The events are empty. Our for loop starts. This is our first time through the loop. We have no events. We're not updating anything. We draw everything. Right here, when we're presenting and we start waiting for 16 seconds, I move the mouse. Let's say I move the mouse 1 pixel. When I come back up here, my events is actually going to have that mouse movement. Now, I don't care if the mouse moved because I'm not telling anything to move, so I can ignore that event. So let's say we go through all the events, we do nothing, and then we go again. And this time, when we get down into here, say here, I tell it to close. I press the X up in the top right-hand corner of Windows or something, and I tell it to close. Well, it's going to keep going. It's not going to close. It's going to go here. It's going to wait 16 seconds. And then back up here, one of the events is going to be this request to close the game. So if we have something that's listening to that event, now we can close. So that's what's happening. We have a queue of events waiting for us. We can go through all those events one by one, and then we carry on. And then when we come back up, we have a new queue of events that happened after the end of the last queue, all the way up until we got up again. So every time we go through this game loop, 60 times a second, we may or may not have a queue of events waiting for us. I mean, maybe no events occur at all, but if they do, we want to go through them. So the way we do this is by we do a pull event, and this is going to get us a queue. This is going to basically, from the queue, the internal queue of events that SDL has, this is going to give us one of those events. This is going to, if we have a variable called event, let's say, it's we're going to use the address of it to write to it. But let's just say we have this variable called event. When we call this pull event, we're going to populate that event with one of the events on our queue. And we can check it and do whatever we want with it. And then we can pull it again. We can pull the next event. And that'll populate our event variable. So every time we're doing this, we're populating our event variable with one event. And then we can check it to see, is this a quit event? Is this a key press event that I'm looking for? And we can go through our whole queue of events this way. So this is what we're going to be using right now. And in this, it has int, but in the actual package, the pull event is going to be returning a Boolean, which is nice for us because the Boolean tells us, is there an event here? If it turns back, if it returns false, that means it finished the queue. There is no more event. So if it's true, there is an event. It's been populated. So we can see that we're calling it event here, the variable, and we are saying it is a type pointer to an event. Okay, so we're going to use this, and this is going to be the little SDL dot pull event. So up here in the events, to get this, we're going to go SDL pull event right here, and it's giving us that we need some kind of we want the address of an event to be able to populate that event. So it wants an event to already exist, and it's asking for us to give it the address of this event so that it can manipulate it. So what I'm going to do is I'm going to create an event and put it into the struct up here. Now you could do this lots of ways. You can create it over and over again, but I don't think we need to create it over and over again. A lot of people I've seen coding in different languages do that. They go ahead and inside of their game loop, they will declare the event over and over again every iteration, and there's no need for that. I'm just going to do it one time. So I'm going to call it event, and I'm not going to make a pointer to an event. I'm just going to make an event, but when I pass it in there, I'm going to pass in the address of it. So this isn't a pointer now that I'm making. This is just an event. So it's going to be an SDL event. Okay, so that's just an actual event because I'm going to use it as the actual event. But when I use pull event to be able to store that event into this, sorry, it's event, not even, I'm going to use the address of it. So in here, where this G is, I'm going to get the address of it. Okay, that's going to populate the event for us. Let's see if it complains about that. Okay, so the one thing we know about this is doing two things. One thing that this is doing is taking an event off of the event queue, and it's populating it into our event variable. The second thing it's doing is it's returning a Boolean, whether this has been populated or not. So we can use this as a for loop, you know, like as a while. But our for does the same thing. We can go for, and while this is true, we can keep running this. So basically, we can do something where we check this event. And when it's done checking that event, we can get a new event and a new event until we've run out of events. So how are we going to check this? Well, the first thing that we want to do is check the type of the event that we got, because it might just be a quit event. If the type of the event is just a quit event, we don't need to check anything else. We could just tell the game to quit. So right here we have the pull events, and we have this event type. So over here, I'm going to open this up. I've already opened it here. The event that's populated can have all these, it's a union, and it can have all these different fields. But one thing we know it has is a type. Okay. And they've messed up the site, so it's a little bit harder to read and understand than it used to be, but I know what I'm looking for is called event type. It's over here. It is harder to navigate now, but if I check the type of the event, one of the possibilities is this SDL quit. So if I see this, I know I want to quit the game. I know that the user of the game has asked that this game be closed. So let's do that first. I'm going to do this with a switch statement. So let's just see how I wrote the switch statement. And this was also confusing to me. And if anybody knows how to program in Odin very well, maybe they can explain this. But when I made the switch statement, well, let's just do this right here. I'm going to copy this. Because this has tripped me up and I still don't quite understand why I need to do this. So I'm running a switch statement, and what I'm doing is I'm switching on the event type. So we know we've populated this event. So here's the event that we just populated. And inside of that, there are different fields that may be or may not be filled or used. But type is in every single one of them. So however it's being done here, we definitely know we have a type. That's in all of them. So one of the types is SDL quit. Now this for us will be the small SDL, but we know there's a quit. So that's one of the options for this, the case. I believe it's case, and then, oh, hold on. I'm maybe writing this wrong. Yeah, that's the way it is. Okay. So it's going to be SDL quit colon, and what we want it to do is to return. Not sure if I've got this all written correctly. I don't think I have this written correctly. Yeah, I got an extra. Oh, it's dot. Sorry. It would be a type dot quit. So it's not dot SDL, it's just dot quit. Okay, so basically we're saying pull the events. If this was true, this has been filled with an event, with one event, we're going to check the event. We're checking the event's type. If that event, the case is, if the event type is quit, we're going to return. So what happens when we return? Well, game run is the game loop. So when I return from this game run right here, I end up right here. And that's the end of the program. It's just going to close. It's going to defer game cleanup, it's going to run, and then OS exit's going to run. So that's just going to close the game. What's tripped me up here is this. If I read in the documentation about the switch statement, it says this right here is fine, right? And it's going to complain I have unhandled cases. But in the documentation, it says I should be able to do this. And that doesn't work. Let's look at the documentation. So I must not be understanding something here. Okay, so this isn't the SDL. This is just Odin Lang docs overview, yeah? And so switch statements, yeah? So the switch statement is like if else, okay? And we're seeing this stuff, and then where's the unhandled? Somewhere down here there's an unhandled. Right here. With union types, I'm looking for this one right here. This case colon is supposed to be default. A switch statement without a condition is the same as a switch true. Yeah, I read it as case is a default. In Odin, the default case is denoted as a case without an expression. So if we have case and just colon, no expression, that's the default, right? A switch statement is another way. Right? In Odin, the default case is denoted as a case without any expression. So I read it as we need a default. We have unhandled cases, we need a default. This should be the default, right? And I tried continue and different things in here. It doesn't work. Is it partial? Partial switches. So yeah. So if I use this partial switch, it's fine because it's not trying to switch on the whole thing. But it's not clear if this is right or not. Yeah, so it's telling me there's a default, and that's what you would need if you have unhandled cases, but then there's a partial. So it doesn't make a lot of sense to me. So I'm using this partial switch to get around that, I guess, or I guess it's the right or not the right. I'm not really sure. I'm new to Odin, so if anybody knows the answer, they can, write it down or something. So that's one, that quit should work for us, right? Let's just try that real quick. Now we should be able to close the window when I tell it to close. On my system, there is no X. On my system, I use Super Shift C. So that's what I'll be using to close the window. So Super Shift C, and it worked. Okay, so this is working. The other thing I would like it to do is close when I press a key combination, and this will set us up for other, or not key combinations, a key press, and this will set us up to be able to use keys later as well. So we have the event, and we just checked the type. So there's another type that can be on the event. Let's go to the event here. Event type. So there's the quit event, but there's also key down event right here. So let's check if a key down has been pressed. So I'm going to add another event to this. And it's just going to be dot key down. And they show up as the enumerated members, which is nice. But with this key down, we need to find out which key we have pressed. So I'm going to run another switch statement on this. And it's, again, going to be a partial switch. But this time I want to drill down to the actual key that's being pressed. So I'm just going to paste this here. It's going to complain about stuff for a minute here. So what do we do here? We have the event, but I no longer want to check the type. What I want to check is what key was pressed. And the way that I'm going to do that is over here in events, we had the type, but we can also check a key right here. So instead of checking type, I want to check key. So I could put key, but that's not going to get us all the way there. Let's look at this SDL keyboard event. And that is here, SDL keyboard event. So inside of keyboard event, we have the key that was pressed or released, key sim. So this is the next thing I want to look up, but this is the dot. This key sim is the dot here that I'm going to drill down into. So I have key dot and then key sim right there. Okay, but I want to look into this SDL key sim right here. So if I open up SDL key sim, this is the structure that we're down into now. And what I want to look at is this scan code. The physical keyboard, virtual keyboard, current. Yeah, I'm just going to use the scan code. So again, I'm going to type scan code. Now this is the actual thing I'm switching on this time. So that is what I'm switching on. And now let's look at the scan code. So I'm going to use this SDL scan code. I'm going to open up the page for that. And this is just all the scan codes to all the different things. And I want the escape. So this is going to be SDL underscore scan code underscore escape. And we know that we're going to get rid of the first SDL underscore, and it's probably just going to be dot scan code escape. Actually, it's just going to be dot escape. Let's check. Yes, it's not saying it here, but it is going to be for Odin's version. Scan code. There's keysim. Yeah, here's scan code. So it doesn't have all that written. It's just going to be, so for us, for escape, it's just going to be writing escape. And it's going to be the same. It's going to be the case dot escape. And you see the language server is helping us out with that stuff too. So if we have the escape, we're going to do the exact same thing. We are going to just return. This should be a colon on this. So now when I open this, when I open it, I can close it by telling the window to close, but I can also close it by pressing the escape key. So let's try that. Okay, I'm going to press the escape key now. There we go. And I'll try the other key, or my closing key combination rather. Okay, now I'm going to try just random keys like space, H, J, letters, numbers, nothing else does anything. So it's escape closes. So that is working correctly. So now we have the better part of a game loop here. We have our events we're checking. We have our drawing of our assets. We don't have any updates yet. We will get to that, but so the next video we'll just be doing these updates. We'll be adding something in there. So let me just show this again. It is a kind of confusing to read this, but we have SDL pull event and it's populating an event. If I were to click on this, it opens up this page here. And these are the events. And the way that you look at it is this is the dot. So if I have event, it's event dot type. So this over here is the type. This on the other side, it doesn't work for this one. It's just SDL event that I had to figure out myself. But for everything else, I can go ahead and open up this page. Like say for key, it's dot key. And if I want to see what's inside that dot key, I can open up this page here, the SDL keyboard event, which is this page right here, SDL keyboard event. And I can see what's inside of that. And it's the dot keysim that I want. Okay. And I can open up this page, the SDL page for this, that shows me what's inside of that. So this is how I'm drilling down. And then again, it's the dot scan code, and I can open up the SDL scan code page, and I'm getting the actual scan codes. And for, they're slightly different for Odin, but it's everything else is pretty much the exact same. So we have this event variable that we've created and put inside the game struct. It's just an event. And then we're populating that event in a for loop. So there could be one event in there. If there's one event in there, this for loop will happen one time. If there's 10 events in there, it's going to give us one event, do all this, and then it's going to go get the next event. It's going to do it 10 times. So this is populating the event, and then this partial switch is checking. First, we're switching on the type of the event, if it's a quit or a key down. If it is a key down, we're switching on which key it was. We can put more keys in here later, so it makes it easy for us. We can just add cases, you know, if it's the A key or the space key or whatever. This is easy for us to add stuff in the future. And when we return from here, we're not returning any Boolean error or anything like that from the game run. There's no error coming out of here. So we're just running it directly. So when we return, there's nothing left in this procedure. So the program is done and it's going to close as per how it was already closing. And we have changed this delay. Again, this is in milliseconds, 1,000ths of a second. We've changed this to 16 to get us in the ballpark of 60 frames a second. This is not exact, but it's good enough for this. Yeah. Okay, so I hope that was entertaining or you learned something. And that's going to be all for this one. So thanks for watching and goodbye.